what can you tell me about this problem here?
15th degree
Careful.
binomial.
15th degree binomial. 11. So this is, why? This degree, the degree of this term is 8, but that one's 15, so that's the high. So it's a 15th
Degree binomial.
degree binomial.
And binomial pretty means it's only it's two exponents.
By 2 terms. Right?
Two terms.
What about this guy here?
Okay.
You'd have an 8th degree trinomial, right?
Ninth degree.
No, 10th degree.
Ninth degree.
10th degree.
8th degree.
Why is, because D is
Not a polynomial.
not polynomial.
That's a quick
8th
one.
degree.
Why is it not a polynomial?
8th degree
Ruh-roh.
polynomial.
Right? All I need is one little mistake, and the whole thing's not a polynomial. What can I not let D be, really?
Negative.
Careful. What can I not let D be?
Zero.
Zero, because it would be 1 over D. D can't be 0. Polynomials are supposed to be able to take anything.
Yeah.
So I see a negative power, and that's basically what we are going to be mostly concerned. I'm not going to throw radicals at you because we haven't done it, but I want to show you that that would not be a polynomial. You're not going to see that from me, though. You're going to look for these negative powers or variables on the bottom. That's where there would be a problem. Polynomials can't have problems. They're supposed to be nice functions.
So that negative at the end of that at the end
Throws the
of
whole thing off.
throws
Oh, it
the
does?
whole problem off.
Because now, for the whole thing, I can let D be anything here, but it can't be 0 over there. So this whole thing is not a polynomial, right? So this is just not. So don't let that trip you up. It's not a trick question. It's a quick one.
The radical, so the radical.
It's gotta be a whole number.
You can't have a variable in a radical.
You have to multiply it by a radical and it'll just put one right back on top, kind of thing?
Don't get too far yet. That's what I meant. We haven't officially done radicals yet. So, okay.
So it's gotta be a whole number.
Yeah. It's got to be a whole number power.
If you have
Could be
a,
zero.
And it could be 0 because of any constant has x to the 0 in there because that's just 1.
One, yeah.
Yeah. What about this one? Here, what about this one?
so if you have a
All right.
negative 1, it
Yeah, you're
automatically
ready.
makes
Gonna
it
write
not a polynomial.
something like that. There. All right.
Whole number.
Careful.
No variable.
What's the
No.
word?
That's a whole number, yeah.
It's not a polynomial.
It's a
It's a mono.
Monomial.
Like a monocle, right? One lens.
like a
So it's a monomial. What degree monomial?
1st degree.
0 degree.
Oh, 0 degree.
If you say 1st degree, you better be able to find a variable in there.
And you can't.
I see 0 variables, so it's a 0th degree monomial. All right. That's enough of that.
So
That's
about number 4, if you have a negative exponent, it automatically makes the entire equation not a polynomial.
A polynomial must have no problems anywhere. That has a problem somewhere. And that is a part of this whole thing, right?
Yeah.
Don't look at it like these guys are all like, you jackass. No, this is one thing. We were almost there. No, this is one thing.
So if
It
there's
has a problem at 0.
so if there's a negative, it automatically turns it to not a polynomial. Okay, I got you.
All right. Now, the rest of this section, yeah, Pat,
Obviously, we're not gonna be adding.
that's what, I like this segue. The rest of the section really is just like terms. And the nice thing about polynomials is, normally the exponent that people hate the most is the negative powers. Are you going to see negative powers when I'm talking about polynomials?
No.
Just
Absolutely
say,
not.
no, you're not going to see negative powers, right? If you do, it's a quick answer.
Not a polynomial.
So when you're doing these, it should be easy. It should be like, holy crap, this is just like chapter 1. It's just like terms now, right? They're going to ask you to add these 2 polynomials, we'll just put the like terms together. And I'm not going to really go over that because that's something we know. So, starting on page 391, number 13. All the way through page 293, that's all stuff we've done before, right? The worst they could do is to start throwing variables in there.
0?
Yes,
0 th degree?
0th, yeah. So just to make sure we're all on the same page with like terms, it should be easy, but what do you guys think about this here?
First
So
power,
that would be, eight,
It's a
eight B.
first power trinomial.
7A.
First
No,
power.
no, no, it's four.
Would it be binomial?
What do I have here? I got 11 ABs.
Yes.
Do you have anything else with an A and a B in it?
Yeah.
6.
Good, so these are like terms.
Yes.
Right.
11 ABs minus 6 ABs, I just put it out of order, who cares?
Five.
So you have 5 AB
5 ABs.
plus 2A.
Two A.
And can that guy go with anybody?
No,
Aw.
Adreno squared.
because AB is one thing. Correct.
What do I mean when I write, in fact, I wrote 11 AB up there.
AB
What does that
is one
mean?
thing.
What does that mean? That means AB plus AB plus AB 11 times,
Or
right?
A 11 AB.
So if I add these, the powers will never change. If you do this, that's an interesting claim to make. You're saying you have 5 of these, and I don't see any of them up there, right? I don't see any A squared B squares up there. I see several A B's up there. And exponents are based on what operation? Exponents are based on multiplication, right? 3 cubed is 3 times 3 times 3. So what's the only time they can change when I multiply or divide? I cannot change exponents when I add, because they're not based on addition. What changes when I add?
The number.
Because
The whole
this
number.
means 5 of these added. I've got 11 of them added, minus 6 of them added, I've got 5 of them added left,
Right.
right?
So they're not multiplied by 5 times.
I mean, that's another way to look at it, but coefficients in one way means I got 5 of these things added together, right?
How would you put that into multiplication? Just so I don't get confused.
How do you mean?
Like I said, like they're not being multiplied.
Well, it
AB
is
not multi-
5 times AB, I agree with you.
Okay,
But what does that really mean? I got 5 of these added.
okay, I see, same thing.
So when you're doing addition and subtraction, you just change the number in front of them, but when you're doing multiplication or division, you like square them.
Then the exponents would change too.
Okay.
Yeah. Right. If I have, so for, if I have 11AB times 6AB, what's that gonna be?
It's gonna be 66
A squared.
A squared plus B squared times B
No,
squared.
plus, it's only multiplication there, yeah?
Right.
Okay. That's when the exponents will change because they're based on how many things I'm multiplying, right? So I really want to make it obvious. There's no way they can change when I'm adding and subtracting because they're not based on addition and subtraction, right? Same thing we said before. Why is this easy? What is that? 2 times x plus y.
2x plus 2y.
Because coefficients are based on addition. They should play well together. Remember this? Why is this one more difficult? I have to write it twice, multiply
You
it
have
out.
to
Because
foil it.
exponents don't play well with addition. right?
You'd have to
Same-
foil
same
it
idea.
and then,
Cool.
X
Yeah.
squared.
Regarding this one, so the solution, it is second degree binomial?
Oh, if I asked you what type of thing it is, sure.
Yeah?
It's a second degree binomial, sure. But I'm gonna keep those separate. I'm not gonna ask you to do a lot of work and then say, okay, now, what is it?
because you'd have A1 and B1 and that would be,
Exactly. This will be second degree, first degree, the whole thing is second degree then. So I just wanna see, there's 2 terms of binomial.
Okay.
Okay.
it's not too hard.
That section should be, let it be easy. Don't let the definitions get you down.
On to 5.3.
5.3.
Man.
And I'll let you guys try a few of these out.
Oh, great, we're foiling.
I am going a little quickly through this section because this should be reviewed
Distributing.
for the most part. So again, this whole thing is all about these polynomials, right? So if I multiply a monomial by a binomial, that makes it sound all impressive and formal and crazy. But what does that really mean? It means this.
Single. Double.
That's a monomial as a binomial, right? And of course, what's the property?
Distribution.
Yeah. And the really nice thing again is you won't see negative powers because these are supposed to be polynomials,
Right.
right? So this is just like the stuff we were doing before, just easier even.
Which one is the monomial, the 7y?
No, come on now.
And 3x squared.
There's one term
3x squared.
multiplying by 2 terms. Monomial times binomial.
Yeah, because xy is its own term, and then
And
x
this
squared.
thing here, do you see any pluses or minuses here?
No,
Well, actually,
So this is one thing together.
and that's what xy is as well.
Why is that two terms here?
Parentheses.
No, it's the minus sign between.
Minuses and pluses separate terms. So this is one term, right? In fact, you know, how many terms are here? How many terms?
One.
One. One big ass term, but it's still one term. And they're all connected, right, with multiplication. That would still be a monomial. Okay. So here, don't let this be difficult either. Just because they're starting to use these terminologies, it doesn't matter.
12x to the third.
12, I love it.
X3.
X3,
Y to the second.
Y second.
y squared,
Minus 21.
21,
X to the second, Y to
X,
the
Y
second.
to the second.
11, right?
And now you have two,
And you can say to yourself, I have 2 x's times 1 more is 3 x's. I have 1 y times 1 more is 2 y's. I mean, that's, if you have any trouble with that, that's how you say it to yourself.
and now you have two monomials or a binomial and a
No, what do you
monomial?
have now? I have a
Binomial. So two binomials.
We did this in 90, yeah.
I have a binomial right there. That's a binomial. A binomial, right?
So they're monomials by themselves, if you were to have them.
Yeah.
Okay.
Okay, Jeff, give us an evil one.
Huh?
Give us an evil one. so
All right, you
that-
asked for it.
Yeah, that way.
Well, let me build up to it.
No freaky ones yet, thank goodness.
I mean, here's the next level. This is a whole, no, level. Let's see. No, Nomad TV.
Foil situation.
I guess it is kind of old.
It's a 2 binomial.
Yeah, exactly. Binomial times binomial.
Yeah.
And of course, what do we do here?
Foil.
Foil. Now, stay with me now. What does foil mean? You guys learned about foil a long time ago?
Outer, inner, last.
Outer.
Now, to
Factor
tell you honestly,
first.
there's nothing wrong with it. It just doesn't help you on more complicated problems. All you're really doing is, here I only have one thing to distribute, right?
Right.
Here I've got 2 things.
Right.
So distribute the x first,
Yeah.
and then distribute this.
Right.
And that first, outer, inner, last,
Yeah.
right?
Yes.
So either way you look at it, for 2 and 2 is fine. But what if I start putting 2 and 3? Foil goes out the window.
Yeah.
It'd have to be full minimum. You'd have to have 4 letters, right? You got the middle times the last and the first times the middle. Oh God, no. So you just think x times both of those, so x times y. xy.
XY.
Negative 5ab.
Plus.
No, it's plus 6 ABX, right?
If you want.
And then
Right? This
minus
times
Yeah.
this.
Minus
These
5
guys?
ABY.
5 ABY.
Minus 30 A squared B squared.
38, A squared, B
And do I have any like terms in there?
No.
squared. No.
No, I have no like terms in there, right? No more xy, no more abx.
So that is a
Polynomial.
polynomial.
I like it. That is a polynomial, that's right.
A big ass polynomial.
Like a trinomial times a trinomial.
Okay, let's do it.
With a 4th degree polynomial.
Your guess.
I know.
Oh, see.
It's killing me.
Oh, this is fun.
All right. Now see, foil quickly leaves the building.
Reason?
Foil looks at this and says, "Hold shit,"
I'm out
and
of.
takes off. That's why, personally, I wish they really wouldn't teach foil. It helps, but not all the way. Just teach distribute, one thing at a time. So how many things do I have to distribute
3
here?
by
3.
You gotta distribute the x. So what do I get?
X squared.
X,
X squared.
Minus
minus
x.
X, 1X,
Minus X.
xy.
X, Y.
How we doing? Now I gotta take the -1 through.
You're gonna make one big line? Yeah.
yeah. Minus
Negative x.
Jesus Christ.
1. Negative y.
And then I gotta bring
Now you're gonna have like
what I have
terms.
left here.
Sheesh. Combine like
Minus
terms.
YX.
Not yet. I still gotta bring this through, don't I?
Oh, yeah.
Minus
Christ almighty.
Plus x, right?
Yeah.
I mean, plus not x.
Y.
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 Thank you. And then minus.
Minus
Y
Y
squared.
squared.
All right.
No.
Now you have like terms.
And then you put your like terms together. I like it. Wow. But that was
Things have
a
canceled.
semi-long problem. Not really, but sure.
Semi-long.
But people give up halfway through, or they forget to keep going. You just take this guy all the way through, this guy all the way through, this guy all the way through. Now collect everything. Do you have any more x squares?